Morning to one and all. Today we are going to see about dimension analysis. In our fluid mechanics and machinery subject, dimension analysis is one of the part of the syllabus. So why we are need to do dimension analysis? What is the major reason that we are going for dimension analysis? Since we can't explore all the experiments in reality, so we are going for a prototype and model concept, right? Here we are going to test the prototype by replicating its model, and in which all the tests as geometric similarity, kinematic similarity and dynamic similarity all were has been given to that model, and the test has been conducted so that such that the possibility of constructing a better design can be observed. So these dimensional analysis were used in many of the research areas to conduct a test on models and design of many components. So usually we can't determine all the essential facts based on the theory alone. So to do experiment, we can greatly reduce the number of tests needed by using this dimension analysis. So there are two different methods of doing this dimension analysis. One is Rayleigh method of analyzing this dimension, and second one is Buckingham Theorem method. So in this video, we are going to see about the technique we are using to determine the dimension analysis of a problem, that is called Buckingham's Theorem. So in this technique, there is some arrangements has to be made. So what are the arrangements, or what are the assumption that has to be done in this Buckingham theorem? We need to know before going into or before solving a dimension problem. So in this technique, we need to arrange parameters into lesser number of dimensionless group of variables. So based on fundamental dimensions, though, so we know the fundamental dimensions such as mass, length and time. So let x1 and x2, x3 up to xn be the n dimensional variables. So if you are given with the problem of various n dimensional variables, we can solve using this Buckingham theorem. So the major difference between Rayleigh's method and Buckingham theorem method is, in Rayleigh's method, we can solve up to with the maximum of 4 number of variables dimensionalization. If it exceeds number 4, then it will be difficult to solve using the Rayleigh's method. Since the fundamental dimension is limited to 3, so we cannot go for maximum number of unknown variables. The equation will become complicated and it is difficult to solve using Rayleigh's method. So we are choosing Buckingham theorem for solving the method with the given n number of dimension variables. So we can write dimensionally homogeneous equation with relating these variables as function of x1, x2 up to n number of variables given, which is equal to 0. Here we need to consider that there are two different variables, dependent variables and independent variables. If we are given with a problem in dependent variable, we need to choose. So what is the dependent variable and what are the independent variable? But all the variables should be considered before solving the problem as a n number of variables. So we can arrange this equation into the following, where phi is the another function and each phi term is independent dimensionless product. So this Buckingham theorem states that pi is a dimensionless group. So it is having a dimension of m power 0, l power 0 and t power 0. It is a dimensionless number. There is no unit for these pi terms. We are arranging such that by selecting a repeating variables. There is some method to choose that repeating variables. The repeating variables that are chosen should be such that it should have one repeating variable should have a geometric similarity. The second one should be having a the first variable selected should have a geometric property. The second variable selected should have a fluid property, and the third variable selected should have a flow property. The repeating variable should be selected in such a way. We will see in the problem. So the first step in Buckingham theorem. So let us focus on an example as we work through these steps. So drag force Ft on a submerged sphere as it moves through a stationary viscous fluid. So identify the variables and count the number of variables. Here the total number of variables is 5. See, F function of drag force, right, Ft, and as it moves through a stationary viscous fluid. So the sphere having a diameter d, velocity v, density rho, and dynamic viscosity mu. So these are the variables we need to take into account for considering solving the problem. So here you can see that Fd, drag force, is a dependent variable, whereas diameter, velocity, density and viscosity are independent variables. So to solve the problem, you need to consider all the variables. So the total number of variables will become 5. So whereas the fundamental dimension m is 3. So mass, length and time. So how many dimensionless term or pi terms will be framed using these variables? So it is n minus m terms. So total 5 variables and fundamental m variables are 3. So 5 minus 3 will be getting 2 pi terms for solving this problem. So dimensionless terms formed in this problem are 2 pi terms, right? In step 2, list the dimensions of each variable. So you need to identify the dimensions of each variable in MLT system, that is in dimension unit system, and find the number of fundamental dimensions. So here the drag force can be written as force. We already know that force equal to mass into acceleration. So kg meter per second square. That kg can be written as m, and meter can be written as l, and second square can be written as divided by t square. So this is the dimensionless term for force, drag force. Whereas for diameter it is l, meter. Whereas for velocity it is meter per second, which means l by t. Whereas for density, kg per meter cube, so which is m by l power 3. For dynamic viscosity it is m by lt. So there are fundamental variables m equal to 3 fundamental variables. So mass, length and time. So we can, so in the step 3 we can see define the reduction number. How much usually we need to choose the dimensionless term. So find the reduction number k, usually which is equal to m, cannot exceed m, rarely less than m. So try to find the m dimensional variables that cannot be formed into a dimensionless group. If m are found, then k equal to m, right? Okay, in step 3, m equal to 3, we have found out 3 basic dimensions, fundamental dimension m, l and t. So now we are going to arrange that drag force is dependent on these variables. So k equal to m, which is equal to 3. So step 4, this is the dimensionless group, as I have already told you. So number of variables is 5 and number of m variable fundamental dimensions is 3. So 5 minus 3 you get 2 dimensionless group. In step 5, select k variables to be primary repeating variables that contains. So as I have already told you, the repeating variable should be selected in such a way that one variable should have geometric property, the second variable should have flow property, and third variable should have fluid property. So here we can choose the flow geometric property, which is containing diameter, and then flow property we can choose velocity, whereas in the fluid property we can choose density. So then select k variables to be primary repeating variables contain all MLT dimensions. So here we have framed 2 dimensionless terms with repeating variables selected in such a way that it contains geometric property, flow property and fluid property. And then remaining variables we can take into account, that is dynamic viscosity and drag force. Here you may note that viscosity and density both are fluid property. So it is nothing wrong in choosing density or viscosity as a repeating variable. The solution won't change. You will be getting the same answer if you chosen dynamic viscosity as a repeating variable. Step 6, equate components of each dimension so that in terms of sides of pi terms. So as I have already told you, pi is a dimensionless number. So equate the power on both right hand side and left hand side, and you can observe step 6. So here we can see working with the first pi term. So the density, as we have already know dimensional form group, density is kg per meter cube, m by L power 3 to the power a1, diameter L to the power b1, velocity L by 2 to the power c1, dynamic viscosity m by L t. So here we are equating the powers on both sides. For m we can get the equation as a1 plus 1 equal to 0. For L we are getting equation as, here you can see, minus 3a1 plus b1 plus c1 minus 1, which is equal to 0. Then we are equating for t. For t, here there is one term, t power c1, t power minus c1. So here we are writing as minus c1, and then here it is in the denominator t. So we are writing it as minus 1, which is equal to 0. Then so we are equating this equation. So here we can write directly written as a1 equal to minus 1. From this third equation we can written as c1 equal to minus 1. Substituting a1 equal to minus 1 and c1 equal to minus 1 in this equation, we get b1 equal to minus 1. So here we can see that pi term we have formed is rho power minus 1, d power minus 1, v power minus 1 into mu. So which is equal to mu by rho Vd. So we already know this equation, mu by rho Vd is nothing but a Reynolds number. Then now we are going to working with the second pi term, pi 2 equal to rho power a2, d power p2 and v power c2 into fd. So we already had discussed these terms, and now we are going to write dimensionless term for fd. Now we are equating powers on both sides. We will get a2 plus 1, which is equal to 0, minus 3a1 plus b1 plus c1 plus 1 equal to 0, minus c2 minus 2 equal to 0. Now we are equating this equation. a2 equal to minus 1 we will be getting directly, whereas c2 equal to minus 2 will be getting directly. So substituting this c2 equal to minus 2 and a2 equal to minus 1 in the equation. So we'll be getting b2 equal to minus 2. Now we are going to substitute these powers in this dimensionless terms. So pi 2 equal to rho power minus 1, d power minus 2 and v power minus 2 into fd. So we'll be getting fd by rho d square v square. Now we are going to rearrange the pi groups as desired. So function of, as I have already told you, pi 1 is a function of some pi 2. So fd by rho d square v square equal to function of Reynolds number, or we can write it as rho mu by rho vd. So fd equal to rho square d square v square into function of Reynolds number. So we can see that in the above equation we can see the drag force of a sphere moving in a fluid with a velocity v and dynamic viscosity is clearly depending upon the Reynolds number. So use dimension analysis to arrange the following into group into dimensional parameters, you can solve the problems. Thank you.